Hello everyone. This lesson is on numerical solutions to equations, and this one will be concerning iteration. You'll find this on page 278 of the Pure Maths 2 textbook. Okay. What we're going to do then is we're solving equations. We're solving equations of the form a function of x equals 0. And this is an example of what we're going to do. This equation is a quadratic equation. Now, we all know how to solve a quadratic equation. We could use the formula in this one, and we'll get a solution, two solutions for this. X equals, minus b, which is 1, plus or minus the square root of b squared minus 4ac, which is minus 4, divided by 2, and that gives us two solutions, 1 plus or minus root 5 over 2, which is approximately 1.618 or minus 0.618. Okay, well, let's consider what these mean. We could sketch the curve y equals x squared minus x minus 1, which will look like that. And we can see where the curve intersects the axes is where we have the two solutions. Now, let's look for a different approach. The point of this will be in order to solve equations where you can't, you don't have a formula, you don't have an analytical method. So, what we do is start by rearranging the equation, and we want to rearrange the equation so we get x equals another function of x. In this case, we can write the minus x minus 1 on the other side. We'll get x squared equals x plus 1. Take the square root and get x equals the square root of x plus 1. That will obviously be the positive root. We could also go for the negative root. X is minus root x plus 1. Now what we're going to do then is, if we were to sketch both x, y equals x, and y equals the square root of x plus 1, we would get this. We would get, this is here, the y equals the square root of x plus 1, just half of that curve, because we've only got the positive part, and y equals x, a straight line. And we can see that the positive square root is here, and that would be, if I went down there, that would be our root, and that value was around about 1.816. 618 even. 1.618. Now, the technique for solving this equation, though, if we didn't know the solution, so supposing we don't know that, and we're trying to find that value, rub that out, I'm going to call that alpha. And so what we're going to do, we're going to guess a solution. Let's supposing we guess a half. And that first solution we're going to call x0. And 0. and x0 is a half. What are you doing? So we have x0 equals a half, 0.5. Okay, so if we have x equals the square root of x plus 1, so we're going to do the square root of a half plus 1. So x0 is a half. Maybe we'll put down the square root of x plus 1 here, and that would be the square root of 1.5, and that we'll find if we go to the curve, and then so that value there would be the square root of 1.5. Now what we're going to do is we're going to use that value as the next iteration. Okay, I've just tidied this up a little over here. So I've written xn, and xn plus 1 is a root of xn plus 1. Because what we're doing is we're doing iteration. So we're starting off with x0 as a half, and so your x1, your next value, is the square root of a half plus 1, or the square root of 1.5, which is about 1.2247. Now, that x1 is, what I do is, I go from the point there, that's on the y-axis, that would be the square root of 1.5, and I'll then go over to y equals x, because we want that to be our next value, x1 down there, and then what I do is I substitute that into x plus 1, square root of x plus 1, to get x2, which means going to putting that into root x plus 1, that takes us to the curve, and that will be that value there. So x2 would be the square root of 2.2247, etc., which is about 1.4915. So that's our value for x2. We go there, and that will be the x2. And we can carry on in this way. And the next one, we would go up to the curve and along, and that would be x3 in there. So x3, we would do the square root of 1 plus 1.4915, and that would equal about 1.578. Now this diagram here is known as a staircase diagram. So what you're doing is you're taking your first value, so let's make it a little thinner. Your first value x0, which is like a guess or an estimate, usually x given to you. You go to the curve, and then so you substitute into the function on the right, and then you use that value for your next one, and then you use that value for your next one, and that value for your next one, and you get closer and closer, you converge to your root alpha. So your alpha is approximately equal to 1.578. Of course, I can do that as many times as I want, and you'll get closer and closer until you find that alpha is, if I did it about 7 more times, I get approximately 61803, etc. So you get closer to the root that we found. Now, that wasn't the only way I could have rearranged the equation. I could have just written, factorised the first two terms, x minus 1, and added 1 to both sides, like that. And then written x equals 1 over x minus 1. Again, we have the form of our x is a function of x. That is what we're trying to achieve. X is a function of x. And our iterative formula would be x to the n plus 1 is 1 over x to the n minus 1. This is known as an iterative formula. It's a way of taking a value and then getting another value by substituting it in to the next value in the sequence. You've got a sequence of numbers that converges to the solution. Now, if we did this and drew the diagram, you get the rectangular hyperbola there, y equals 1 over, oh no, what? Okay, so this is a rectangular hyperbola, y equals 1 over x minus 1, and we have y equals x, and we see where they intersect is where we have the two roots. This time, let's consider the negative root over here, and let's choose minus 2 as our starting point over there. And you see what happens if we now apply the process here. So that's the value of 1 over minus 2 minus 1. So then we go to we make that the next value. That's wrong. So the next value of x, so we go over to, we go over to the line, which is to there. So that's our next value, that'll be our x1. And then we use that, we go to the curve, and then to the line, and then to the curve, that'll be our x2. And then to the line, if I can go across there, and then to the curve, that's our x3. And basically, we go round and round. We alternate between greater than the root and less than the root. So the book shows this better here. Here's the first value, minus 2. Then you put that into the curve, you go to the line which is over here, that's x1, go to the curve, that takes you to x2, go to the curve again, to the line, that's x3, and then round it again. And this time you get this other sort of diagram known as a cobweb diagram. The thing to watch out for is you could rearrange it this way, a very simple way of writing x to the n is x squared minus 1 by just taking the x onto the other side, starting with x is 2. And if you did it here, you can see in that diagram what will happen. You go to the curve, you go to the line, you go to the curve. In fact, you get further and further away from the root. And that, for a sequence to converge, which will mean like a diagram like that, or one like that, the derivative or at the root must be between 1 and minus 1. So it has to be less than like that, a gentle gradient like that. If it's a greater than 1 or less than minus 1, so it's steep,